Okay, welcome back. Last time we learned some terminology about curved mirrors. We learned about concave and convex. We learned about a focal point and how to label image distance and object distance, image height and object height. Now I'm going to show you how to find an image formed in a concave mirror. For now, imagine an image formed by placing a small candle in front of a concave mirror. This is the object. Notice it is beyond the CC, the center of curvature. The CC is twice the distance of the focal length. So, how do we find where the image will form? Unlike a flat mirror, the image will not form with the same distance on the other side of the mirror. Instead, this time it will form a real image, but in a new location. So we're going to draw some lines in here. I'm going to use a ruler. And the first line I'm going to draw is going to be parallel to the principal axis. It will bounce and hit the mirror and come back through the focal point. I'm going to call that ray 1. It's part of the definition of a focal point. Any ray parallel to the principal axis will bounce back through the focal point. But if we take the opposite of that, if it comes in through the focal point, it should return parallel to the principal axis. And I'm going to call that one ray 2. And finally, we don't really need any more, but if we want to draw a third, this one should go through the center of curvature. You can see my center of curvature is a little off there. But the three rays 1, 2, and 3, should collide at a single point. That point will be the same top of the candle that it started from. And I have an image here. If I want to describe this image, I can describe it in three ways. The image is a real image. This means that it is on the same side of the mirror. It has a positive image distance. If we had a negative image distance, it would be on the other side of the mirror and it would be virtual. It is inverted, which means it is on the other side of the principal axis. It actually has a negative image height. And it's slightly smaller because the height of the image is less than the height of the object. Okay. Now I can also find this mathematically. If I imagine that my candle has a height of 5 centimeters, has a distance away from the mirror of, let's say, 40 centimeters, and the focal length of this mirror is 15 centimeters, then I can calculate where the DI should be, and later I can calculate what the HI is. So I'll start with my equation. If I do, I die. 1 over 15 focal length equals 1 over 40, plus, oops, that's supposed to be an I, plus 1 over DI. Now as I get my calculator out here, an easy way to do this is to say 1 divided by 15 minus 1/40th, and then take the reciprocal of that. Take the reciprocal of that, and I find that the distance the image is from the mirror is 24 centimeters. However, now that I know DI, I can also use the Hi-Ho equation. I don't know the height of the image, but I know the height of the object we said was 5 centimeters. We just solved for DI. Notice the negative that's in the equation there. And DO was 40. I'm now going to cross multiply, divide by 40, and because of the negative sign, HI will be negative 3 centimeters. Notice it is closer. Instead of 40, the image forms at 24, and it is smaller